Hey, what's up? I'm Austin Griffith, and I want to talk about counterfactual instantiation. It's a lot easier to digest if you call it something more like predictive deployment, and it's almost like keyless predictive deployment, or keylessly signed predictive deployment, or trustless predictive deployment, something like that. Basically, predictive deployment. You can craft up a transaction, and you know exactly what that transaction is going to do, and then you can push that on chain, and it's going to come from a specific signature that no one actually, or a specific private key that no one actually owns. So what can we do with that, right? Well, the fact that you can craft a transaction that people can agree on off chain, and you can craft a whole bunch of them, right? This is like all off chain, and then only put it on chain when you need to, is kind of pretty powerful. So there's a really good tweet storm here from Jeff Coleman about what counterfactual, like where it kind of started, and the I guess the TLDR, you should get on and read it. Definitely check it out in this article. But the TLDR is like, you're not just governed by rules on chain, but you're governed by rules that could be on chain. So if there's a way for two people to sort of like trustlessly agree on a rule set and have that rule set still exist off chain but only come on chain if needed, then they're probably going to be good actors, and they're probably going to kind of stick to their word because of that. So that's kind of like the counterfactual idea, is like you only need it when you need it, but we can also use it to predict where the address will be. And you can even do some stuff where you're like mining, you're like switching out the signature and trying to find a specific type of public address, whether you need leading zeros or you want a specific identicon. There's a bunch of stuff about it in the article. The key thing I want to address is this problem that Dharma's having, where when someone repays a loan, Nadav tweeted about it here. When someone repays a loan, they have to approve some smart contract to take their tokens, and then they have to go call a function on the smart contract. And it would be really nice if it was just a transfer, because any wallet out there can do a transfer, but to do this with to call the function, to do the approve and the function call, you almost need a custom dApp. And I think it's very powerful to just be able to use a wallet rather than have to use a custom dApp every time you want to go repay a loan or whatever. So the trick here, I got to give a lot of props to George Spazov and Alex Van de Zandt. They introduced me to the idea. They put all this code together in multiple files, and I just brought it into a single file. But there's this nice little counterfactual toolkit that I think that we'll iterate on. But it lets you basically drop in a contract and some arguments, and it'll spit out the transaction that you need. So it's like a nice little command line tool, and I made a video about that already. It's probably in this article somewhere. It's this one here, where I'm not wearing a bow tie. What a slacker. And then so we're going to use that script to kind of address Nadav's problem. And what we're going to do is basically, we're going to, let's just get this thing started. So there's command lines. You can follow right along with it. I've already brought it up because it takes like 5 minutes to fire up. But I'm going to run the Clevis test full, which will get the whole test suite up and running and ready to go. What we're going to do is basically build a specific sweeper contract. And that sweeper contract is here. And that sweeper is very simple. It does exactly what we want the user of the loan to do. It crafts up an approve, or it doesn't craft up, it just calls approve, just the ERC20 token standard. It says, hey, this address is allowed to move my tokens. And then it just calls repay on the loan. The two things that we wanted the user to do, we're actually going to have the contract do. And then we'll just have the user send to wherever this contract is going to land. And then eventually, if the user pays it back, then we kind of counterfactually deploy this thing. It'll sweep up all their funds. It'll call the address that needs to be called. And everything happens on chain that we need it to happen on chain, without the user having to do all that work. And so you could totally do this with a trusted third party, right? Like, you could just send me your funds and I could put it on for you and call the function for you. But this is trustless. That's the key to this. Is it's like these keyless signatures, right? What we're doing is we're actually taking a transaction that works and we're carving out the signature, and we're replacing it with some specific arbitrary parameters that basically say this is a random signature, and then we'll fund the address that sort of would own that signature, and then he'll deploy it. So it's like a one-time deployment. There's no way anybody can mess with it, and if the funds go there and we don't sweep them correctly, they're locked there forever too. That's another thing to talk about. Okay, so basically we have deployed this counterfactual loan repayment dApp, and it's a so I just took this loan and I made a loan smart contract that's very, very simple. There's a repay function and an issue function, and the repay function just marks it as paid on chain and moves the funds around. So like this is probably not even close to the Dharma setup, but it's just like a very, very simple idea of how a loan might work. So we're going to issue a loan. Oh, you know what? I need to get the backup or the backend spinning up. So the backend actually goes and talks to that script and gets everything running. So we need to have that up and running too. So we're going to issue a loan to this guy here for 100 tokens. So the balance right now is 5,000. Oh, I deployed a coin along with this, just some coin. So there's the loan contract, there's the counterfactually deployed sweeper contract, and then there's a coin contract. So I'm going to issue a loan for 100 tokens to that dude. And we should see the loan go through over here. We should see this guy collect some 100. So, okay, so it also, this backend service called that craft function. And that craft function created a transaction for us. And now it's stored on our server and we're ready to run it as soon as this person pays back their loan. And this is what the end user gets, this nice little printout. Well, obviously it would look a lot better than my UI, but they get this nice little printout of like, here's your loan. We've loaned you 100 coins. When you're ready, go ahead and just pay them back to this address. And I'm going to copy that because we're going to need that in a little bit. And right now you've paid back 0, right? So this nice little accounting piece, they don't have to worry about calling smart contract functions. They don't have to worry about approving. They just send it to this address, right? So let's say it's time. Let's say they've used the funds for whatever they needed. They've generated them back. Everything is good. Now it's time to pay their loan back. So they can go into any wallet. I have it built into my dApp, but you could do this with MetaMask easy. You would just say, hey, I want to pay 100 some coins to this person, and you put some coin in as a token. It's easy. But I'm going to put it in the dApp just so it kind of flows nicely, but you do not need a custom dApp to pay back this, and that's a cool piece. So we can see that this identicon and this identicon are equal. We're going to send back 100 to that address, and we're going to go ahead and hit send. And that's going to be our one transaction. It's going to be a simple, we're sending 100 some coins. Okay, look, now over on the admin side, we can see that like, okay, they've paid back their loans. It's time to collect it. We've kept that transaction secret in our database ready to go for when this person is ready for us to sweep it. And now we can collect. So that's going to go run the counterfactual transaction. That's going to deploy that sweeper contract to the address that we already knew it was going to go to. And then it's going to do the approve, and it's going to call the repay, and the loan gets marked as paid on chain. So this is just a quick run through. Check out the whole article. There's a lot more to it and a lot of interesting stuff, and I try to do it like piece by piece. If you have any questions, hit me up on Twitter. Counterfactual loan repayment or predictive deployment, right? Doesn't that sound better? Or maybe keyless predictive deployment, or maybe trustless predictive deployment. I don't know. Anyways, thanks for checking it out. Counterfactual stuff is just another tool in our toolbox, and we'll keep building that toolbox up. Awesome. Thank you. Happy Bowtie Friday.